Morning. This is a video I'm doing about another one of my circuit boards I had printed. This is this. Let's get some light in here. This circuit board, which is basically a overly complicated version of the old Estes rocket launcher. It's pretty much one of these. This is an old Estes rocket launcher. It's a very, very simple design. There's four AA batteries in here in series for 6 volts. Power goes through this light bulb, through this, there's a switch in here, and then through the, when this is closed, this actually fires it. So when there's batteries in this, you would connect these 2 connectors to the rocket, to the igniter on the rocket engine, come back to the launcher, and there will be no light. You plug this key in. If there's continuity between the igniter, so if the igniter's wired correctly, then this light would light. When you press this button, it shorts out the light, closes the circuit, and allows all the voltage, the current, to go through the igniter. So effectively what this is there's a circuit going between the batteries and the igniter, but because this light bulb is here, it's taking all of the current. If you're familiar with what a dim bulb tester is, that's basically what this is. So once again, when you push this, it shorts that out, and when it does that, it fires the rocket. So mine is kind of like that, but kind of some extra safeguards, kind of overly complicated. Kind of hard to see also. The basic circuit, which I'll put up on screen, and works like this. You have 2 connectors marked as H2, H1 in the, or B plus, B minus in the diagram. Power comes into there. The power goes from B plus through the relay common, through the normally closed connection to a resistor, and to in this case I'm showing there's 2 versions of this. There's an LED, and there's a way you can do this with an incandescent lamp. So when there's no key inserted, then the safe LED is lit. No power is going from the relay to the igniters or anything, because without the key inserted, it won't switch over. So we have 2 connectors here marked key 1 and key 2, and when the key is inserted in the switch, it closes the connection, power goes through that. The resistor is only there if you're using a relay that's different voltage than your power source. In my case, I'm using 2 18650 batteries, which produce 8.4 volts. My relay is 5 volts, and so I have a resistor there to reduce the current. Reduce the voltage, so that relay coil doesn't get fried. So you put the key in, the relay switches over, and it will send power to the resistor and the igniter it sends power through the resistor and to B1, which is one side of the launch button, and this lights the armed LED. Now, when you use the LEDs in this circuit, there is no continuity checking. When you're ready to fire, all you do is you press the button. When you press the button, that closes B1 and B2 and sends power to the other side of resistor R4 and to the igniter plus. Igniter minus is already connected to ground, and that will fire the rocket. Now, this does not check for continuity, so the only way you'll find out if it works is when you apply power. R4 is there to take the voltage so that the LED doesn't blow out when you hit the ignition button. It will get brighter. So now for this configuration that I'm actually using, what we have is the same basic configuration. Power comes in, B plus, B minus, goes to the relay, goes through key 1 and key 2. When the key is inserted, it closes the relay. But in this case, the LED on the safe has been replaced with an incandescent bulb, and the resistor R2 has been replaced with a jumper. It still shows in this schematic a resistor and LED because I'm lazy. On the other side, once you've put the key in and it switches over, if igniter IGN1 and IGN2 are connected to the igniter, the lamp will light, because the circuit is completed through the lamp. And when the launch button is pressed, it shorts out the lamp and fires the rocket. So this is how that looks. Now, I'm not actually going to press the fire button at this moment. I'm just going to show that if we have an actual igniter, and we're going to apply a current limited power to this. And let's get this where it's visible. This is the key switch. I'll show you with the whole thing put together how that works. But when the key is inserted, if this igniter is connected, the red light will light. And now I will disconnect the igniter. And press it again. Nothing happens because it's showing there's no continuity for the igniter. So now I'll show you the other one, the LED version. And I don't have that in a case. I wasn't planning on actually using it. If we hook it up to power. So in this instance, if you can, I don't know if I can see that. Let's see. Alright. That's the green LED, the safe LED. This switch is just playing the part of the key lock or key switch. So I put it in and it turns red. There is no continuity testing between this. This light right here is shoot. Sorry. All right. This light right here is taking the place of an igniter. So we've put the key switch in, switched over to red. You press the launch button and power goes to the igniter. So that's how that one works. Alright, so I'm going to put this thing back together and then come back. Okay, so I'm just briefly showing you my progress. I have the key lock installed. That's the switch in here with a piece of red plastic that keeps the key in from wandering. I installed a couple of standoffs, and I've got the circuit board installed, and now I just need to close it up. Okay, so we have power hooked up to this. Get that out of the way so you can see. The part of the igniter will be played today by a 12-volt light right here. By the way, these two bulbs in here are 12-volt bulbs, so this can be powered by up to 12 volts. So you can see we have power plugged in. If I press this button, nothing happens. Press, insert the key, and because there's continuity between the light bulb and this light bulb is let's try that again. So we have power coming in, put in our key, switches over to armed because we have continuity in the light bulb. Press this button and this light goes out, and that light lights, which indicates that the rocket would have fired. So that's it. Thanks for watching.